Hello and welcome to lesson 17.2 in the Python tutorial series. I'm Steve, and this lesson is going to be a continuation of lesson 17.1. The last lesson we introduced the elif and else statements as part of our conditional checks, and today we're going to provide some more examples of that, though not in the same context. If you watched lesson 7.1, we created a function that took some information, how much money we had in our wallet, how much money someone was asking to borrow, and then finally whether or not they were a friend of ours, and determined whether or not we were going to loan them money. And we did so through if, elif, and else statements. Now today's lesson is going to be a little bit more straightforward in that we're just going to be using numbers, but the real purpose of lesson 17.2 is to trace the flow of an if, elif, and else conditional check to see what's going to execute, why it's going to execute, and how you can use that to debug your programs and provide you, the programmer, some information that you might need. Finally, we're going to end today's lesson with the challenge program, which is going to be a leap year program, and we'll get into that in just a little bit. So let's go ahead and get started, continuing with if, elif, and else statements. Over in our programming window, we're just going to write a little bit of code to help us watch how the if, elif, and else statements flow. I'm going to start by setting a variable x equal to the number 15. And then I'm going to do a series of checks. I'm going to say if x is greater than 20, I'm going to print the statement greater than 20. I'm then going to do an elif statement and say if x is less than 18, print less than 18. I'm going to do a third elif statement. If x is equal to 15, I'm going to print is equal to 15. And finally, I'm going to add an else statement, which says in all other cases, I'm going to print nothing is true. That means that it skipped all the checks and everything turned out false. So when we look at this program right here and execute it, what you want to ask yourself is, what do you think is going to print? What is the result of running this program going to be? When I hit F5 to run this, I can see that we're printing less than 18 and nothing else. If we follow the flow control of this program right here, I can see x is equal to 15. The first check is made, x is greater than 20, that's false, so the check is skipped and the block of code is not executed. The next check is made as part of an elif statement, x is less than 18, that is true, so the block of code beneath the elif statement is executed. When Python encounters this elif statement, if x is equal to 15, that indeed is true as well. However, we've already executed an elif statement, so the block of code is going to be skipped. Not because it's not true, it's still going to evaluate to true, but an elif statement has already been executed. And finally, it's going to make this last check, and the else statement will evaluate to false because something above it has been executed. So the else statement will be ignored. If I were to change these statements, let me go ahead and comment out the else statement because this will create a problem, and change these statements here to if statements. When I execute this program here, I'm going to get two items that print on the screen. X is less than 18 and x is equal to 15. Since these are if statements, they're all handled independently and each one that's true is executed. However, if I change these to elif statements, the elif statement is paired with the if statement that comes before it, and you can almost think of this as one giant block of code here. Only one of these blocks of code will be executed, and what determines that is which statement is found to be true first. Let's make a slight change to the program that's on the screen here. Let's change x to a value of 24. I want you to take a look at that code right there and ask yourself, when this program is executed, what is the shell going to display? What's going to show up on the screen on the left? If you've been following along, it should be pretty easy to determine what's going to happen here. But you want to make sure that you can look at something this simple and identify it on site without having to run it. When I execute this program, I can see indeed greater than 20 prints out. And the reason is, of course, x is equal to 24. So we make our first if check. X is greater than 20, and that's true. So greater than 20 prints out. And all the other statements are going to evaluate to false. X is not less than 18, so this is ignored. X is not equal to 15, so that block of code is not executed. And since one of the statements, in this case, our first if statement, was found to be true, the else statement is ignored. And finally, let's change x to a value of 19. Think about this program, look at the lines of code on the right, and ask yourself, what is going to print when this is executed? When we execute this program, I get nothing is true. The reason nothing is true prints is it makes the 3 checks. X is not greater than 20, that's false. X is less than 18, that's false. X equals 15, that's false. And since all the previous statements, no matter how many there could be 10 Elif statements there, but since they were all found to be false, this else statement executes, and the shell prints nothing is true. Now, if I were to get rid of this else statement right here, get rid of it completely, technically this is still correct. But when I run this program, nothing prints out. The reason nothing prints out is the else statement handles a case where nothing that I check turns out to be true. Now, you have to be careful when you're writing programs like this that you don't create some impossible logic. And what I'm talking about is, let's provide a fourth example here. Let's set x equal to 15 and run this program. I get less than 18 that prints. And it makes sense. 15 is less than 18, so that's going to print. What we've done is we've created a check here that one of our Elif statements is impossible to execute. Under no circumstance will this Elif statement ever be executed. And it has to do with where it's placed in order of these checks. If you follow this through, x equals 15, we make our first check. Is 15 greater than 20? That's false, so we move on to our next check. Is x less than 18? Well, 15 is less than 18, so we're going to print less than 18 and ignore all the other checks. In essence, x equals 15, while true, will never print, because if x equals 15, it is inherently going to have to be less than 18, and this line of code that's highlighted on the screen will always be the one that executes. At no point in time could this block of code ever execute, because if the number is 15, it would have to be less than 18. It has to do with the ordering. If I were to change the order and move this Elif statement and put it above x is less than 18, when I run this program now, I get x is equal to 15. That's because I'm making this check here and finding that, yes, x is equal to 15. That's the block of code that gets executed, and now we're ignoring x is less than 18 because we've already found a true statement. Now, all of these checks here could possibly run. If I were to change x to a value of, say, 10, I'm getting less than 18 to print. That's because 10 is not greater than 20. 10 is not equal to 15, but 10 is less than 18. So you have to pay a little bit of attention to the order in which you're making your checks, because they will execute from top to bottom, and the first true statement is what prints when you're using an Elif statement. And you can create a situation where you have checks that will never be executed because of how you have your program set up. Okay, so let's go ahead and clear our programming window on the right. And imagine for a second you're writing an adventure game and you want to print a menu and have the user select one of the choices that you give to them. This is where an elif and else statement can really help out in some of the earlier programs that you're going to be writing. Let's go ahead and print a main menu for our user. So we'll use a print statement with main menu and add a little bit of flair to it. And let's say option number 1 is going to ask them if they want to pick up an item. Option number 2 is going to be, let's see, wear an item. And option number 3 will be to drink a potion. And so those are the only 3 options that we want our user to be able to select. When they make their selection, we can use an else statement to give them feedback if they're not selecting a valid option. So let's go ahead and add an input statement. We're going to store it in a variable x. X equals input, make a selection. And so now the user is going to be prompted to select one of the items from our main menu. And we'll add an if statement and say if x equals p, then we're going to print object picked up. Else if the user selects w, we're going to print object is worn because they wanted to wear their item. And their final option was D, drink a potion. And if they select D, we're going to print you drink a potion. So it's not unlike other menus that we've done in the past, but with the else statement, we can now add feedback if they don't select something off of our menu. When we execute this program right now with no else statement, and I select P, the object is picked up. That's exactly what I want to happen. If I select D, I drink a potion, and that's exactly what I want to happen. But what happens if the user selects something that's not on the menu? For example, S. Right now, my program doesn't do anything. By adding an else statement, I can say print invalid choice, select again, or some other appropriate message. And now, when my user selects something that's not on the menu, for example, S, they get an invalid choice message. Same thing works if they select Q or anything. If they don't even select a letter and instead they choose 14, invalid choice, select again. That else statement becomes a catch-all where you as a programmer know that one of these things have to be true. And if none of them are true, you know something has happened. Either the user hasn't inputted something correctly or your checks aren't quite right, because one of those 3 things in this situation must be true, and if it's not true, we know we have an invalid selection. So that's a way that you can use the else statement as a catch-all when you're having users input information. So with that being said, you should have a good handle on the if and elif statements. Let's go ahead and start challenge program 17.2 that deals with calculating leap years. In order to do today's challenge program, you're going to have to know how to calculate a leap year. And there's a number of places on the internet where you can find out how to do this, but the quickest and most succinct that I found is a site called Math is Fun. So let's surf over there real quick and take a look at how you determine whether or not something is a leap year. So from Google, you could pretty much just type in how to determine a leap year and get any number of sites on how to do this. The site that I'm going to go to is Math is Fun and Leap Year. You can see the top of the search results, Leap Year's Math is Fun, pulls up this website right here, and it's just a really quick explanation of why we have leap years and how they're calculated. But the important thing for you in your program is going to be this highlighted section right here. So as you know, every 4 years we have a leap year where we have the 29th of February. And there is a way to determine whether or not a year is going to be a leap year. There's 3 conditions that are checked. Leap years are any year that can be evenly divided by 4. So in 2012 we had a leap year, in 2016 we're going to have a leap year, in 2020. So any number that's divisible by 4 is a leap year. Unless, so the exception is if the year can be evenly divided by 100. So 2100, 2200, 2300, those years are not leap years because they're evenly divided by 100. However, if a year is evenly divided by 400, then it is a leap year. So 2000 was a leap year. The year 2400 will be a leap year because that's divisible by 400. So those are 3 conditions right there. And if you are so inclined, you can scroll down to the bottom of the page and it will also explain why we have leap years and all the little technical information about it, I guess. It's pretty simple and sometimes it's interesting. But this portion of the website right here is what's going to be most important to you. You have a series of checks you have to make. Is the number evenly divisible by 400? Is it evenly divisible by 100? And is it divisible by 4? And then using those rules right there, you're going to have to write a program in which the user can input a year and the program will tell them whether that year was a leap year or whether it's going to be a leap year. So on the screen here, I have my simple leap year checker that I programmed based on that information. It prints an introduction. I don't have it running in a continual loop. I have it just run once, execute, check a number, and then it's done. It does print an introduction message. Welcome to the leap year checker. You're going to be asked to enter a date. The program will let you know whether or not the year selected is a leap year. So let's go ahead and check the year 2000. I know that the year 2000 was a leap year, so I'm going to type in 2000, and the program has identified that 2000 was a leap year. I'm going to check this year, which is 2014. 2014. Now, 2014 was not a leap year. Primarily, it's because it's not divisible by 4. And sure enough, my program is able to identify that 2014 is not a leap year. Let's go ahead and try the year 2300. Is the year 2300 going to be a leap year? It is not going to be a leap year. That's because it's divisible by 100 and not divisible by 400. So all I've done is taken those series of checks from the Math is Fun website and used a series of if, elif, and else statements to determine whether or not a year is a leap year or not. And the way that I did that is I created a variable called leap, and then I set it to true or false depending on what conditions were met. So at the end, when it prints the year either is or is not a leap year, it's doing so based on a variable that I set is either true or false. So that might give you some hints on how to structure this program as you go into it, but you should be able, with the information that you have, to write a leap year checking program using the conditions from the Math is Fun website. As always, if you have any questions or problems while you're trying to build these programs, go ahead and let me know in the comments and I'll get back to you as soon as I can to help you with any of the challenges that you face. Otherwise, best of luck. Thank you so much for watching and have a great day.